Okay, in this part of our lesson, we're going to be learning a new method for solving systems of equations. In this lesson, we'll be working with elimination. So to solve a system of equations by using elimination, you want to line up your equations so that the variables are in the same position and eliminate the ones that will cancel each other out. Then you're going to solve for that variable and substitute in for the other variable. So here's an example. We have an x minus 3y equals negative 4, and our second equation is negative x minus 2y equals negative 1. In our previous lessons, we've always gone through and worked to get y by itself. In our solving for substitution, it was either x or y. Algebraically, we tried to always get it to say y equals, just because we were used to graphing those. When we graph them, we get it into the y equals format. In this, we don't have to go through and do that, but we do have to make sure that we get our x's and our y's in the same position in each equation. So when we look at this sample that they're giving us, and they talk in that first step about making sure that they're lined up, well, notice that we have our x's stated first, then our y's, and then our number. Okay, so it's in that standard form. Now, what we want to do is we want to go through and see if there's ones that have opposites of each other. They're the same, but exact opposites, because that's going to cancel each of them out. So I'm going to put a 1 in front of each of these so that we're seeing the numbers there. So really that's a 1x and a negative 1x. Those are opposites, which means they're going to cancel each other out. Ultimately, what we're doing is instead of lining this up horizontally like we're used to when we work through algebraically, we're going to line them up vertically, and we're going to be adding these together. So when I go through and I look at these, I have 1x minus 1x. Well, 1 minus 1 would give me 0 x's, which cancel each other out. Now we'll go through and simplify the rest of the equation. So we have a negative 3y plus a negative 2y gives me negative 5y equals negative 4 plus negative 1 gives me negative 5. Okay, this is where I highly recommend just double checking yourself on the calculator, double checking with a partner to make sure that you're not making a simple mistake with your integers. Now we're going to go ahead and solve to get that y by itself. So right now it's negative 5 times y. We're going to divide by negative 5. Divide by negative 5. I find out that y equals negative 5 divided by negative 5 is a positive 1. So in my x-y combination for my system of equations, I just found out that y is positive 1. Okay, so now that was the first part, was to go through and line them up, which they were already lined up here, eliminate, which is what we did here. We eliminated the ones that were opposites of each other. And now we're going to go through and actually substitute in. So we solved it. Now we're going to substitute in. In this case, it really doesn't matter which equation I pick. I'm going to pick the top equation, and here's why. Because I want to solve for x. I'm noticing that on that top equation, x is a positive. It's not a negative. So to save myself a step, I always want to pick where there's a positive variable. So it doesn't matter that the y is positive. It's just the fact that I want it to say x equals and not a negative x equals. So if I put a 1 in where this y is, okay, so I have x minus 3 times 1 equals negative 4. So if I go through and I solve that top equation, it becomes x minus, 3 times 1 is 3, equals negative 4. And then we would work to get x by itself, so plus 3. Plus 3. I just found out that x equals negative 1. Okay, so to prove that it doesn't matter which equation I pick, I could go through and do the same process with this one. It's just that when I substitute or when I solve for x, I'm going to have a negative 1x there. It's going to add one additional step. So if I substitute in, so I have my negative 1x minus 2. Y was originally 1 equals negative 1. Okay, these together give me 2. So negative 1x minus 2 equals negative 1. So then I would do a plus 2. Plus 2. Negative 1x equals positive 1. And then I would go through and I would divide by a negative 1. So 1 divided by negative 1 is still going to give me -1 for x. So take note, it really didn't matter which equation I picked. I try and pick the one that's the least confusing. So if I don't have to work with the negative, I prefer not to, okay? So we're gonna go ahead and practice quite a few of these. Okay, so here's another one. So once again, first step, line up to make sure that you have your x's and your y's in the same position. If you have to, you can write them spaced out like this if I wrote this out, because I'm not liking how it's looking right now, the way that I have it typed out. Just make sure you copy everything exactly the same. Like I almost forgot the negative on that 30. Okay, I'm gonna put a 1 with that. And then I have a positive 4y equals a -10. So when I do this, I'm looking at my x's and my y's and I'm checking to see, do I see either of them that are total opposites? They have to be the same number, but one has to be positive and one has to be negative because I need them to cancel each other out. Okay, we are really doing addition between these, but remember you're working integers, so it's not always adding. So I'm noticing here, these are not the same. My x's, I have a -5 and a +1. In my y's, I have a -4 and a +4. There's my canceling, my eliminating. They're exactly the same. Okay, so now I'm gonna go ahead and I'm gonna work going down to see what I have left over. So I have a -5 plus 1 gives me -4x equals -30 plus a -10 gives me -40. Once again, highly recommend checking with a partner, double checking yourself on a calculator, okay? So now I'm gonna go ahead and get x by itself, so divide by -4. Divide by -4. I get x equals -40 divided by -4 gives me a +10. So in my x-y combination, I just found out that x is 10. Okay, so now I'm gonna go back to one of these equations. It does not matter which one, okay? I'm gonna use some problem solving skills and the fact that I wanna use as least amount of steps as possible. So if I already have where it has the x by itself, that's the equation I'm gonna use. Not that I can't use the -5x minus 4y, but that's gonna give me one more step to do. So I'm gonna substitute in my 10 that I just found out here into this equation. So it becomes 10, where x is, plus 4y equals -10. Okay, that is an ugly 4. Okay, so now I'm gonna work to get y by itself. Okay, so I've got a +10, I'm gonna subtract 10 minus 10. I now have 4y equals -10 minus 10 gives me a -20. Divide by 4, divide by 4. So I just found out that y equals -20 divided by 4 gives me a -5. There's my system, my solution to my system of equations. And just to prove to you on this one, it would not matter which equation I picked. I'll go ahead and substitute into that top equation also, just so you can see that I should still get -5 for my y if I do my math right. So I am going to put a 10 where this x is. Okay, so I have -5 times 10 minus 4y equals -30. Okay, so here I get 50 minus 4y equals -30. Okay, so now we'll add 50 because that's the opposite, and I'm working, I want it to be y by itself. So it's taking us back to that chapter 1 review of solving multi-step equations. -4y equals -30 plus 50 gives me a +20. So then we'll divide by -4. Make sure you take that negative with the 4. 20 divided by 4 is 5. There's one negative. I still got a -5. So take note, it really didn't matter which equation I picked. I strategically picked this bottom equation originally because it just had less steps, less spots for me to make mistakes. Okay, so let's try a few more. Once again, you're only going to get better the more you practice them. Okay, so our first step is when we're looking at this, we want to look to see, In our x's or our y's, do we have anything that would cancel each other out? So when I'm looking at this one, well, my x's are a -4 and a +4. Those are opposites. They cancel each other out. Those are gone. Now I'm going to go through and I'm going to simplify. So I have a -2 plus a +8. That's going to give me +6y equals -12 and a -24. So we're adding those together. So that gives me -36. Now we'll divide to get y by itself. So we'll divide by 6, divide by 6. 36 divided by 6 is 6. And we had one negative, so it's a -6. So our y in our combination of our xy's is going to be -6. Okay, now I get to pick whichever equation I want. Does not matter. I will tell you my personal preference is to go through and use the one that's got, because I'm solving for x, the one that has the positive x, but it really doesn't matter. So I'm just going to use this bottom equation. So I'm going to scribble this one out, and I'm going to use the bottom equation, and I'm going to substitute in -6 where I have the y. Okay, so I have 4x plus 8, and my y was a -6 equals -24. Okay, so that's my next step, is to substitute in. Okay, and you guys worked substitution in a previous section. All right, so now multi-step equation, I got to put these together. So I have 4x, +8, and a -6 give me a negative answer of 48. Double check yourself on a calculator if you need to. Equals -24. Okay, so now we're to a two-step equation. So I want to leave this here. So the opposite of a -48 is a +48. So I have 4x equals -24 plus 48 gives me a +24. Now we'll divide by 4. Divide by 4. 24 divided by 4 gives me a +6. There's my answer to my system of equations. 6, -6 is where these would intersect if I were to graph them out. Okay, but if we, in this situation, if we were to graph it, it would take us multiple steps to get both of those equations into that y equals format, which is where the elimination method takes priority then. If you know that method, it saves you time. Okay, so we're going to go ahead and try another one. Not the same one. No, they're not. They look very similar. Okay, so once again, let's look through. Well, our x's are opposites of each other. We have a +4 and a -4x. So there's our elimination. Gone. So now we're going to go through and simplify this out. So I have an 8y, a +8y, and a +2y. We're adding, we get 10y equals 20 plus a -30 is going to give me -10. And once again, check yourself on the calculator if you need to. Divide by 10 to get y by itself. I just found out in my xy combination that my y is -10 divided by 10 is a -1. Okay, so now I'm going to pick one of the two equations. It doesn't matter which one. Like I said, I like to use the one where I'm working mainly positives, even though I'm substituting in a negative number. Okay, so I know that this y right here is -1. So when I write it, when I get to that part where it's circled, I need to write my -1. Okay, so 4x plus 8. Remember, this is times a -1, not 8 minus 1, equals 20. Okay, so this right here gives me -8 now. And I still have 4x in front. And if you don't like how that looks, you could get rid of that plus sign. I was just copying down exactly what I saw there. So if you don't like to see the plus sign, you can eliminate it out. That's totally up to you. And then I solve equals 20. So our two-step equation here, +8, I have 4x equals 28. Now I'll divide by 4. Divide by 4. 28 divided by 4 gives me 7. So my solution to this system of equations is x is 7 and y is -1. Okay, so if I substituted in those two things into both of these equations, they would be accurate equations. Okay, so we're going to go ahead and test out. Let's try one more. Okay, so we're going to go ahead and do one more. So this one looks kind of different because there's no numbers with that top equation. So let's remember, when there's not a number with a letter, it's like having a 1 there. Okay, so when I look at my x's, those are not opposites. I have a 1 and a 2. Both are positive. When I look at my y's, I have a -1y and a positive 1y. Those are opposites of each other. They eliminate or cancel each other out. Okay, so now there's my elimination portion. So we're going to go ahead and put these together. So 1 plus 2 gives me 3x. My equal sign. 11 plus 19 gives me 30. So now we'll divide by 3 to get x by itself. Take note, in our previous examples, we had to solve for y first because those are the ones that eliminated, or the x's eliminated, and this one, the y eliminated. Okay, so x equals 30 divided by 3, which gives me 10. So there's my x part of my solution. Okay, so strategy. I want to substitute in. Does not matter which one I substitute into. Strategy for me is least amount of steps. So I'm going to substitute into this equation, and here's why. Because it's just an x and not a number connected to the x. So if I substitute in, I just found out that x is 10. So where I have x, I'm going to write a 10 minus y equals 11. Okay, so now to get y by itself, I would do minus 10. Minus 10, and I'm noticing something about my strategy that I don't really like. So we'll discuss this out in just a second. So 11 minus 10 gives me 1. Okay, so here's what I'm not liking about this. Very common mistake is people will write down y equals 1. That's a negative y. So this is why I'm not liking the one that I picked. I am now going to have to go through and actually do the opposite to get rid of that negative. So it's like having a 1 in there. Divide by -1, divide by -1. So 1 divided by -1 is going to give me a -1 for my y. Okay. My strategy to start out with seemed great, but a very common mistake is if there's a negative sign left with that y, a simple mistake is made. People forget that they have to do that next step. So I'm going to prove to you where I could have eliminated that last step here by just deciding, okay, I think I can do 2 times 10 in my head. If I had substituted in 10 there, so 2 times 10 plus y equals 19. You'll see now I have a positive y, so I'm not going to have to worry about that step. So here I've got 20 plus y equals 19. So now I would do minus 20, minus 20. It still gives me a -1. And see how I'm left with a positive y. I didn't have to do that final step. So you're going to have to kind of pick and choose. Like I said, I thought I had a great solution there. And then I noticed, ooh, whoops, I really didn't want to work with that -y. I'm comfortable with solving that, but that's usually where students and some adults will make that mistake. Okay, so that's it for this part of the lesson, working elimination. When they're giving us one of them that can cancel out. So the next part of the lesson, we'll be learning how to go through and solve using elimination if we don't have x's and y's that are the same.